Today, we're going to talk about composition of functions. So what a composition of functions means is that when we're looking at function notation, we take one function and plug it into another function. So let's quickly review function notation. Let's say you have a function, f of x, that's equal to something simple like 2x plus 5. We know that if you replace this x with a number, 2, you are supposed to take the 2 and input it everywhere in the function that you see an x. So that's your input spot. A composition of functions says that instead of inputting a numerical value, I'm going to input in place of the x, I'm going to input a whole other function. And that's what we're going to review today. So if I'm taking a look at the two functions that I have, and I'm being asked to determine what is f of g of x, all that's asking me to do is to input the interior function, or g of x. In this case, that's 1 over x. Input that into the original function for f everywhere that I see an x. So the f function is the square root of x minus 3. And in place of x, I'm going to put the function for g, or 1 over x. And that itself is essentially the composite function, but we can do a little bit of simplifying. So I have the square root of 1 minus x. I do want to combine these two terms. So I'm going to give that a common denominator, or x over x. And that turns into the square root of 1 minus x minus 3x over x. And because those now have the same denominator, I can combine the numerators, and that becomes 1 minus 3x divided by x. And that's it. That's my composite function. So this particular question is asking me to also find the domain of my composite. So here's my composite function, and we need to talk a little bit about how you find the domain, because it's a little bit different than normal. So anytime I need to find the domain of a composite function, the thing that I need to do is I need to figure out two domains. I need to find the domain of the interior, g of x, and I also need to find the domain of the composite function itself. So we're just going to write up here what the composite function was, which was the square root of 1 minus 3x over x. So I need to find the union of the domain of this and the domain of the interior, which is 1 over x. So I'm going to start with the domain of the interior because that's a little bit less complicated. There's a fraction, and I know that in a fraction, the denominator can't be equal to 0. So for this function, the domain is all values except 0, and in interval notation, that becomes negative infinity to 0, comma, 0 to infinity. Okay, now in the composite function, I have a little bit more work to do because this is inside of a square root. So there are two things that are going on. First of all, I also can't have 0 in this domain because I have division by x, but also because the term 1 minus 3x over x is in a square root, I know that whatever the value of this fraction is, it has to be greater than 0 because I can't take the square root of a negative number. So I'm going to cross multiply to simplify this, and I get 1 minus 3x is greater than 0. And I keep solving, and I'll get 1 is greater than 3x, or that x is less than 1/3. So to combine those two things in interval notation, that means the domain must be negative infinity until 0, union 0 to 1/3. So in order to find the domain of the composite, I'm combining this and this, or the overlap of those two things. So you can kind of picture them on a number line. The domain for g of x is a little bit more expanded, but I know that I can only go up to 1/3. So the domain of the composite is negative infinity until 0, union 0 to 1/3, and then the g of x would have you going past infinity, but that would conflict with my original one that goes up until 1/3. So the domain of the composite would be just this.